Okay, we're getting ready to do lesson 2.6 of Algebra 2 Math, Part 2. Part 3 is available here, as well as all of your other course materials. 2.6, finding rational zeros. We've got a 22-point classwork sheet, and today, no points for notebook taking. Here's the standard here. Let's go into our lesson. Classwork sheet, page 1. Verifying zeros. Recall that you found zeros of polynomial functions when one zero was known. The rational zero theorem is the starting point for finding zeros when no is known. So, how do we do that? The rational zero theorem lists only possible zeros. In order to find actual zeros of a polynomial function, f, you must test values from the list of possible zeros. You can test a value by evaluating of x. So let's see what we got here. Finding zeros when the leading coefficient is 1. Here's our leading coefficient. It will be 1. List of possible rational zeros. Leading coefficient 1. The constant term is 20. Here's our constant here. So the possible rational zeros are here. So we use our 1 here as our denominator, and then we put the factors of 20 in here, which is 2, 4, 5, 10, and 20, all over 1 plus or minus 1. These zeros, test these zeros using synthetic division. Now that we know how to use synthetic division, let's put it to use in finding possible rational zeros of that polynomial. So we're going to test first x equals 1 into this polynomial here. Here's our bar here. We're going to use 1. So we're going to get into our synthetic division. 1 times 1 is 1. We get negative 7. 1 times negative 7 is negative 7. We add, we get 4. 1 times 4 is 4. We add, we get 24. So in that situation there, 1 is not a 0. We do not have a 0 here. So 1 is not. Let's try something else. let's try negative 1 for this polynomial here. So here are our coefficients. Here's our constant. Let's do negative 1 now. Drop down 1 times, negative 1 times 1 is negative 1. We add negative 9. So negative 9 times negative 1 is 9. We add, we get 20. 20 times negative 1. And shazam, here we are. Here's a 0. Here, when x equals negative 1, we have a 0. So that'd be the way that you could test through all your values using synthetic division, since it's so fast. And we found a 0 there. So because negative 1 is 0, you can write f of x equals x plus 1, x squared minus 9x plus 20. Factor the trinomial in f of x and use the factor theorem. So in this situation here, we have x squared minus 9x plus 20 equals this here. So we know that x plus 1 is a factor, and we can factor that out of the original. We have this trinomial left, and then this can be factored now into these two binomials. So we have our other zeros, negative 1, and then 4, and then 5 would be the zeros of that polynomial. So now we're going to find all the reals of this polynomial. Students, this is your independent practice here. Pay attention so you can do yours. Find all real zeros of this function. So the possible rationals are here because our leading coefficient is 1. That goes on our denominator, and then our factors of 18 are up here, plus or minus. So we're going to test 1, see what happens there. Here is our synthetic division. We do come up with 0, so 1 is a 0 of this polynomial here. So now that we know that, we can write it. We know that x minus 1, we can factor an x minus 1 out of the original, and then we get this trinomial here. So, because this is x squared minus 3x minus 18, That's our trinomial. We have x minus 1 as a factor. And then this trinomial can be factored into these two binomials here. Here are our zeros for that polynomial, -3, 1, and then 6. These are our zeros. That's how we found it. That is part 2 of lesson 2.6. Part 3 is available here, as well as worksheets, class worksheets, tutoring, tests, quizzes, you name it. Thank you very much.